Hi, this is Jonathan again. Welcome back. We're going to discuss in this topic where you place these controllers. How do you make sure that there's connectivity to them? You can't just throw them anywhere and expect the V-edges to be able to find them. Depending on your requirements, I mean, we may have some IP addressing constraints that may prevent us from being able to place them where we might choose initially. This lesson is going to cover where we place these in the public or the private cloud, or where in the enterprise we place them. And if you're a managed service provider, where would we set up to use that enterprise certificate authority? So when we're done, you should be be able to set up the design requirements on where we should place these controllers. So placing controllers has specific challenges regarding reachability, NAT, and so forth. By default, edge devices are going to establish one control channel to each of the controllers over each transport. You can control this behavior precisely as required. For each transport, you can decide whether a control connection is even established. If you have an MPLS connection that does not have internet access, for instance, you can't create a control connection over to its cloud-located vBond or vSmart, right? Because there's just no way to get there from that connection. So we would actually turn off control connections here. On the screen, we can see the control connection on the interface. By the way, we're showing you here the first taste of a feature template for an interface. We'll get into that in some more detail in later slides, but here's where you would turn off that control connection on the interface. And we'll talk about what the global device-specific and default mean later. If I told you now, it would just confuse things. So we'll leave it be for now. Okay, so all controllers have to be IP reachable from all devices. All right. First, controllers must be able to reach each other. All right. You can't have vSmart not be able to see vBond or vManage. If vManage can't see vSmart, it can't configure it. And then each edge device must be able to reach all the controllers. If a vEdge device can't find its vBond, it has no idea how to boot up and what to connect to. And if vSmart can't talk to vEdge, it has no way of pushing any data to it, all right? And getting that route reflection back when we learn about our tunnels from the other vEdge devices. So you can set these up in many different ways. Normally, from the internet connection, a firewall protects data in which the controllers are placed. Over an MPLS cloud or the customer edge router first terminates that MPLS, right? So an MPLS connection will be connecting to a customer edge from a provider edge. If you're not familiar with MPLS, these are the two controlled nodes on an MPLS connection. From there, normal routing should allow connectivity to the controllers. Routing could be over another network, such as a data center core device. Depending on the setup, a firewall might be in the way between the MPLS and that data center. From a routing perspective, devices in both transport networks, internet and MPLS, must be able to reach the controllers. This means that the firewall must allow controlled access from both sides. IP addresses of the controllers must be routed into the MPLS networks as well. In summary, IP connectivity from an edge device to either of the controllers must work, and the firewall must let the correct control ports through. Okay? And we'll go through what those ports are. So one design factor here is whether your MPLS transport has internet access. If it does, so a lot of MPLS connections connect the sites together but don't provide anything outside of that any-to-any connection. If so, then an edge device can establish control connections through both transports, right? So if I can connect to the internet through my MPLS connection and I have a dedicated internet access connection on both sides, right? I can actually connect to the controls devices that are in the cloud over both connections, and I can maintain redundancy in my control connections. All right. Remember, if the MPLS doesn't have an internet access connection, like over here, no, wrong side of the pen. If it doesn't have internet connection like on the right, then I can only maintain that single control plane connection. If we lose our internet access, we lose access to our entire control connection. Now we'll still be able to route traffic, but we won't be able to distribute, make any changes to anything. Okay. Consequently, if there's a local fault, the controllers are lost. Now the data plane connectivity, we can still go through the MPLS cloud, which we'll discuss in a topic of high availability. But the reality here is, even if we lose that internet connection, we'll still have connectivity over the MPLS. We just won't have control plane connectivity. Okay. So the recommended deployment model is using the Cisco cloud, right, which basically is a way of pre-packaging all of the control services in one connection. So you basically have Cisco manage the vManage, vBond, and vSmart. You don't have to worry about it. You don't have to deploy VMware in a VMware environment. And it's easy to scale, right? The more devices you add, you just request Cisco to spin up more nodes. Now, the requirement here is that every site has to have an internet connection. If it doesn't, it's not going to have a control connection, okay? And if you only have a single internet connection at a site and you lose it, again, we lose that control connection. And remember, the whole goal of this is the fact that it's easier to deploy these. So if you're just starting out, the best method is to use the Cisco hosted, because everything's prepackaged for you. Okay. Now, if you have internet connectivity issues where you only have a single internet connection, this may not be the best solution for you, especially if that internet connection is not particularly stable or if it's in an area prone to failure. Now, if you're on premises, now one of the big things we have to be concerned about is NAT traversal, okay? Because if your so the vBond placement is going to become the crucial point here. If the vBond is correctly placed so that it can detect all the NAT functions, NAT traversal is automatically managed and you don't have to worry about it. So there's two scenarios that we're going to support here. MPLS Cloud and Internet Cloud are connected, right? So through my MPLS connection, I also have an Internet connection. MPLS Cloud and Internet are kept separate, which means I have an MPLS connection, I have an Internet connection, and never the twain shall meet. With a connection, you can have control plane redundancy from the vEdge routers. So if your MPLS connection has a connection to the Internet, you can actually go both ways. Without, you can't have a control plane redundancy from the vEdge routers. My recommendation is to go with multiple low-cost Internet connections, a cable modem, and maybe DSL or 4G or some other Internet access to be your secondary redundant Internet connection. If they're in a data center, we can connect them both over the Internet and via our private MPLS, depending on color assignment. Okay? On vEdge routers, the color attribute helps to identify an individual WAN transport tunnel. You can't use the same color twice on a single router, though. So if you have two MPLS connections, you can't have this connection be MPLS 1 and this connection be MPLS 2. I know some customers do implement redundant MPLS providers so that if a provider has an outage, they have a secondary connection over the other one. So the colors are going to have significance. Colors Metro, Ethernet, MPLS, private 1 through 6 are considered private colors. They're intended to be used by private networks or in places where you'll have no NAT addressing of the transport IP endpoints. Because the expectation is that there is no NAT between two endpoints of the same color, right? So if I've got private addressing between two sites, right, I don't have to worry about NATing between them. So if I've got a 10.1.1.0 network and .1 is on one side and .2 is on the other, we can give those a private color. We're telling vBond that we're using private IP addresses, and it knows that it doesn't have to make any NAT adjustments. Okay? When a vEdge router uses a private color, the router is going to attempt to build out those IPsec tunnels to other vEdge routers by using the native private underlay IP, because we are saying we have a private network. Okay? The public colors that we're going to use are 3G, Biz Internet, blue, orange, custom 1 through 3, default, gold, green, LTE, public Internet, red, and silver. With public colors, vEdge routers attempt to build tunnels to the post-NAT IP address, if NAT is involved. If you're using a private color and require NAT to communicate to another private color, the carrier setting in the configuration dictates whether you use the private or public IP address. When you use this setting, two private colors will establish a session when one or both are using NAT. If the vBond orchestrators are correctly placed and if the colors are correctly used in the interface, NAT is automatically detected and incorporated. For this process to work, the vBand must be behind a NAT function so that the vBond can detect a NAT between vEdge routers. Okay? So, there's a high probability that some of these vEdge devices are going to be behind firewalls. All right? And there are going to be some firewall settings that are going to be required in front of a vEdge. Now, all connections to controllers are coming from the vEdge, therefore no inbound ports must be opened. However, if you're blocking outbound, you'll need to permit the ports on the ports on this slide. The 1, 2, 3, 4, 6 is our primary connection, and we're going to do a port hop depending on whether or not that port's available. Okay, and we'll go over those in a minute. And if a firewall is in front of the controllers, we're going to require a mirror image of this, allowing the 1, 2, 3, 4, 5, 6 inbound if we're not permitting it. Okay. So in summary, in NAT, it's crucial to configure correct color settings on the tunnel interfaces to make sure that we have connectivity and to make sure that vBond can recognize, hey, those two are on a private network, they can connect directly. These two are, that one's on a private network, this one's on a public network. We have to take NAT into consideration. Okay? And the color is the way that we tell you that. Okay? Thank you very much for watching, and stay tuned for additional videos.